Good afternoon, my lovely pre-calculus students. Thank you so much for asking questions. I'm excited to get into it today. Remember, vectors are awesome because they are math applied. So these are questions from 10.5 and 10.6 in your book. For 10.5, number 25, we needed to find a force V that will produce equilibrium when added to the system. Remember, our system was composed of 4 forces, U1, 2, 3, and 4. So this is similar to number 24 in my 10.5 video. We're going to need to find U, which is the resultant vector of U1 plus U2 plus U3 plus U4 using scalar addition. So we're going to add X terms to X terms, Y terms to Y terms. Then we need to find a vector that when added to U equals 0, because remember, equilibrium means that the forces add to equal 0. So when we add all of our U vectors together, 3 plus 8 plus negative 9 plus negative 5, we get negative 3. And 7 plus negative 2 plus 0 plus 4 is 9. So our vector U is negative 3, 9. We then need to find a vector so that U plus V will be equal to 0. When we do that, literally you can just flip the signs. If you want to do the algebra, it's shown there for you, but all you have to do is flip the signs. So our final answer is 3, negative 9. All right, so in 10.6, number 10, we're just using the rules of scalar vector addition again. So you were given vectors u, v, and w. We're performing the operation 1/4 8u plus 4v minus w. Whenever you multiply and divide, you're going to do it to both the a and the b terms. When you add and subtract, you'll only do a to a and b to b. That simple. So the first thing that I did was I took 1/4 and I multiplied it by the whole thing. So 1/4 times the 8 times the 4 times the negative 1. The next thing that you'll do is do another distributive property for each of the vectors. 2 to the first vector, 1 to the second vector, negative 1/4 to the third vector. You'll finally be left with a bunch of i's and j's. You add all your i's, add all your j's, and you get your answer. Let me know if you want me to go over this in more detail. The important thing is that when you multiply and divide, you do it to both the a and the b term. When you add and subtract, you only do like terms, a to a, b to b, or x to x, y to y. Okay, so 10.6 number 35 was very similar to number 34 on the 10.6 video. We're going to be following these 4 steps. 1, rewrite in linear combination. 2, convert to component form. 3, add the vectors. And 4, find the magnitude and direction via our formulas. Magnitude is equal to the square root of a squared plus b squared. And theta is equal to the tangent inverse of b over a. So the first thing that we do is rewrite in linear combination. So basically what that means is you're going to take your resultant or norm, the 30, and you're going to multiply it by the cosine of your angle and the sine of your angle. Whenever you find those two, you just put them in your calculator. 30 times the cosine of 300, 30 times the sine of 300. That'll give you your a and your b component terms. Because remember, a is equal to the modulus times the cosine of theta. B is equal to the modulus times the cosine of theta. Okay? Now, or modulus times the sine of theta. After we get our component form for both of them, we just add the component forms together. 15 to the 61, negative 15 to the square root of 3 to 51, 0.423. When we do that, we get our new vector u plus v. We find the magnitude of our new vector, which will be the square root of a squared plus b squared. That's 80.4. Theta is much easier. We just do the tangent inverse of b over a, and we get that angle. I went through this fairly quickly because I covered it in great detail. It follows those 4 steps. If you would like to go over some problems with me in person, let me know and we'll set up a Zoom meeting. Okay, so number 10.6, number 40 was one that I wanted you to try on your own. It's very, very similar to the example 6 in the book. I was curious how you guys would do with a story problem that we didn't directly go over. Anyway, this figure right here is integral to the problem. So whenever you have a force on forces on an inclined plane, there's going to be 3 different forces. The resultant force will be the gravity pushing straight down. You have the component force perpendicular to the plane. You're going to draw everything from the center of your block. So it'll be the one that goes perpendicular to the line of the plane. Okay? Then we have one that's parallel to the line of the plane. The parallel one will be our A term. The perpendicular one will be our B term, because A is like X, it goes side to side. B is like Y, it goes up and down. So remember that theta is equal to the sine inverse of B over R, and theta is equal to the cosine inverse of A over R. We can use either of these equations to find theta. However, for this one, we only have our B and our R, so we'll be using the sine inverse of B over R. We plug our numbers in and we get the angle, easy peasy. Number 50 is a little bit more complicated. I don't have all the work shown here, I just have the theory behind it. If you would like to go over this with me in person, you are more than welcome to. Anyway, in the question we have a weight suspended from two cables. The book gives you that one of the vectors is v is equal to c times the cosine of 65i plus c times the sine of 65ij. Basically, it gives us our theta and it does not give us our magnitude. We can set up a similar equation for u, but we need to take into account that the u angle is being measured clockwise and we measure angles counterclockwise. So measured counterclockwise, that angle would be 148 degrees. So u will be d, it could be any letter here. We just chose d times the cosine of 148i plus d the sine of 148j. So our u plus v will just literally be adding everything together, and we also know that equals 0, 400. So we can take that equation and split it apart into the x and y components. So our x components are c times the cosine of 65 and d times the cosine of 148. That's how we get the two equations that we need to solve. That c the cosine of 65 plus d the cosine of 148 equals 0, and c times the sine of 65 plus d times the sine of 148 equals 400. You just solve that system of equations. You're going to solve the first one for either c or d, and then plug it into the next one to get the one you didn't start with, and then go back and plug it back in. This is simple algebra. I know you guys know how to do this. The hard part was finding your system of equations. Anyway, when you solve that system of equations, you get 341 and 170. Like I said, the hard part is finding the system of equations. Once you do that, it's a piece of cake. Let me know if you want to go over this in person. Again, thank you so much for asking questions. I hope you guys are enjoying vectors. It's really cool seeing math in action. Anyway, that's it for now. I'll talk to you guys later. Bye.